Hi, my name is Joon Suh Choi, and I am excited to present our work on using large language models to develop readability formulas for educational settings, a collaborative work by Scott Crossley, Yanisa Scherber, Mathis Lucka, and me. It is well established that matching students with appropriately difficult reading materials help improve their reading skills, and educators often use readability formulas to decide what is appropriately difficult for their students. Readability formulas are algorithms that have been trained to predict text difficulty using different sets of linguistic features. Popularized readability formulas suffer from a number of salient problems, one of which is that they are normed based on the judgments of readers from specific demographic groups made on a small number of texts. The Common Lit Readability Prize, or the CRP, was a Kaggle competition hosted to address these concerns. Competitors were asked to develop readability formulas based on the Common Lit Ease of Readability corpus, which is a corpus comprising around 5,000 informational and literary texts labeled in terms of text difficulty through pairwise comparisons done by US-based K-12 teachers. The labels, or the reading ease scores, were scalar values derived using a Bradley-Terry model on the pairwise judgment data. In this competition, all of the winning formulas were fine-tuned BERT-based transformers, or ensembles of fine-tuned transformers. And while these formulas performed well on the task of text difficulty prediction, they require a significant amount of time and digital storage space to run. The goal of this study was to collaborate with a Kaggle competition winner to develop smaller models with quicker runtime, less data storage, and minimal loss of predictive power. We developed 3 new readability models with Doc2Vec, Universal Sentence Encoding, and Sentence BERT respectively, all using the same training corpus from the Kaggle competition. The assumption was that sentence embedding-based models would be small and agile while showing reasonably strong predictive performance. We compared the newer models' performances with the performances of the top 4 Kaggle competition winners and other pre-existing readability models. We used a web-based readability prediction app, the Automatic Readability Tool for English, or ART, to apply these extant readability formulas to the clear texts. We then conducted correlation analyses to compare the correlations between the clear text difficulty labels and the readability formula's text difficulty predictions. We found that correlations for traditional readability formulas reported medium to strong effects with reading ease scores, and correlations for the Common Lit Readability Prize models reported large effects with reading ease scores, which were as expected. The more important part is that one of these newer models, based on a pre-trained sentence BERT model, performed on par with the ensemble models from the CRP competition. The new model also outperformed other extant models not trained on the clear corpus, as expected. The SBERT-based model is more computationally efficient, requires a storage space that is 200 times smaller than the first place CRP model, and its runtime is 100 times faster with reasonably minuscule loss of performance, making it effective and scalable for use in learning technologies. The new sentence BERT-based readability formula is available on the ART application and can be accessed through a graphic user interface or API calls. Thank you very much for your attention, and I would be happy to answer any questions you might have.